Hey, today we're going to look into ionic bonding and their properties. So, some learning points. We're first going to look at how does this occur? What type of what does this type of bonding make? And then how this type of bonding affects the properties. Those are the three aspects we're trying to get across. All right, so looking first. There's three main ways that ionic compounds form. The first is electron exchange. So this is where you have an element like a metal, sodium, and a nonmetal, chlorine. They each are in their elemental form, and an electron comes from the metal to make the nonmetal ion, like chlorine, and then this negative ion attracts this positive ion, and you have linkage. This electron exchange is actually quite rare in the real world because sodium, metal, does not just float around. It's very reactive. Chlorine is never by itself as an element. So again, this electron exchange you're going to find all over the internet, but it's actually very rare. A different way is existing ions attract each other when close enough. Now this is actually very common. So you have ions in a solution, iodine and potassium ion. In another beaker you have lead ions and nitrate ions. They're separate because the water pulls them apart. You mix the two together and you make lead iodide. This lead iodide solid, that would come down to the bottom because their attractive forces are stronger than the water to separate them. So this is very common. This happens all the time. A third example is ions in solution exist and you get rid of the solvent. So if you have salt water, you have a metal ion and a nonmetal ion dissolved in the water. And if you got rid of the water by boiling it off or leaving it in the sun to dry out, you would get salty crust that would be forming. That's the ions forming from ion form into a crystal. And that is the three ways an ionic compound can form. This is really rare. These we'll do in labs ourselves. We'll see these or already have done these in our labs. What are you doing, dude? Alright, so from here, crystals are made. Now with every crystal, you have a metal positive ion attract negative ions. They can make many different shapes, but you could see that one ion is surrounded by many others. Could be 8, could be 6, could be 4. There's all these different structures. We don't need to memorize them. I just wanted to show you there's many different crystals that can form. Now, based off of the way these form, this gives 7 physical properties. Take a moment to copy these down. Alright, well let's look into the why for each of these. So, for an ionic lattice, we've got compounds composed of regular repeating structure, right? You got positives and negatives repeating, held together by electrostatic attraction. That just means the positives attract negatives, negatives attract positives. Now why does this occur? So a positive ion will attract as many negative ions physically around it. See, so like in this model, looks like 4. Before the spacing of them doesn't allow any more to get in. And then those outer ions will attract the oppositely charged ions of others, and so on. So the crystal grows and grows and grows because each of these ions can attract other oppositely charged ions. This leads to some high melting points. So all ions in contact, which we call ionic bonds, with several others. To overcome these multiple attractions, a lot of heat is needed. So we take a look at the multiple choice. So with the before mentioned crystal that we saw and can kind of see here, all of those attractions and ionic bonds need to be overcome. They need more energy, and so that takes a lot of energy, resulting in very high melting points. Now you might notice that some with their attractive forces here, when you have a positive 2 ion and a negative 2 ion, results in a very large attractive force compared to a positive 1 and a negative 1, which would only have a less attractive force. But these are all much, much higher than any covalent bond would have. The last one for this part is why there's strong attractive forces in 3D. So each ion makes several bonds, which of course bonds are strong, much stronger than intermolecular forces. So a crystal has a lot of connective forces amongst this. So this yellow one is attracted to 1, 2, 3, 4, 5, 6 ions. And in order to get that by itself, it would need to overcome all of those. So that's what makes it have very strong attractive forces in a 3D crystal. We're going to continue this in part 2, so why don't you head on over there to see what's what. See you there.